Hello everyone and welcome back to my channel. This is the A+ Tutor. Today we're going over trigonometric functions and triangles, or trig functions for short. Our main trig functions are sine, cosine, and tangent. These are abbreviated sin, cos, and tan, so you'll see them written that way. We use these to find the value of angle measurements within a triangle. So when we're looking at a triangle, we note the three different sides from our angle. From the angle we're analyzing, there's a side that's opposite our angle. There's a side that is adjacent our angle. Adjacent just means next to. And there's a side that is the hypotenuse. Our hypotenuse is always the diagonal side. So depending on where our angle is, we'll have one opposite side, one adjacent side, and one hypotenuse. The ratios of our sides will give us the value of the sine, cosine, or tangent of our angle measurement. We can remember what these ratios are using the word SohCahToa. So goes with our sine, or the sine of an angle is equal to our O over H, which is the opposite over the hypotenuse. Ka is for our cosine. The cosine of an angle is the adjacent over hypotenuse, A over H. And toa is the tangent of our angle, or the opposite over the adjacent, O over A. So by remembering the word SohCahToa, we can use that to find the trig ratios on our triangles. So we can see sine of theta, and theta is just used to represent the angle we're measuring. The sine of theta is the opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse, and the tangent of our theta is opposite over adjacent. We have three other trig functions: cosecant, secant, and cotangent, abbreviated CSC, SEC, and COT. Now, these three functions here are simply the reciprocal of our first three functions. So cosecant of theta is equal to 1 over sine of theta. Or cosecant of theta is the reciprocal of what our sine is, so is hypotenuse over opposite, H over O. The secant of theta is 1 over the cosine of theta. Therefore, secant theta is equal to hypotenuse over adjacent, or H over A. And cotangent of theta is equal to 1 over the tangent of theta, which means cotangent theta is A over O, or adjacent over opposite. And we can see that with this triangle as well, how these relate. Our sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. Now, the opposite and the adjacent side are dependent on where the angle is. So now let's say the angle is in the upper right-hand corner of our triangle. This means our opposite side is now the bottom of our triangle, our adjacent side is now the right side, and the hypotenuse stays the same. But just because our opposite and adjacent sides change, our ratios do not change. Sine is still O over H, cosine is still A over H, tangent is still O over A, cosecant is H over O, secant H over A, and cotangent A over O. Now let's look at these relationships in a triangle with actual values. So remember, we're going to use SohCahToa to remember what ratios correspond with which trig functions. When our angle is in the bottom right, that means that 3 is our opposite side, 4 is our adjacent side, and 5 is our hypotenuse. Let's find the values for all 6 of our trig functions. First, let's start with sine, cosine, and tangent. Sine is opposite over hypotenuse, which is 3 over 5. Cosine is adjacent over hypotenuse, which is 4 over 5. And tangent is opposite over adjacent, which is 3 over 4. Now let's find our cosecant, secant, and cotangent. Cosecant is the reciprocal of sine, or hypotenuse over opposite, which is 5 over 3. Secant is the reciprocal of cosine, which is hypotenuse over adjacent, which is 5 over 4. And cotangent is the reciprocal of tangent, which is adjacent over opposite, which is 4 over 3. Let's look at some examples on different triangles. First, we have this triangle, and we need to find the tangent of A. Keeping in mind SohCahToa, we're going to need to find our opposite over our adjacent side. So when our angle is in the bottom left, 7 is our opposite, 24 is our adjacent, and 25 is our hypotenuse. So the tangent of A is equal to 7 over 24. Next, we need to find the sine of x. So again, using SohCahToa, sine is O over h. When our angle is in the bottom right-hand corner, our opposite is 28, our adjacent is 21, and our hypotenuse is 35. So our sine of x is 28 over 35. This can be simplified. Both of these numbers are divisible by 7, so our sine of x ends up being 4 over 5. Now we have to find the cosine of m. Again, using SohCahToa, cosine is adjacent over hypotenuse. So when our angle is in the upper left-hand corner of our triangle, our opposite side is 27, our adjacent side is 36, and our hypotenuse is 45. So the cosine of m is adjacent over hypotenuse, or 36 over 45, which can be simplified. Both of these numbers are divisible by 9, so our cosine of m is 4 over 5. Let's find the tangent of E. So tangent, as we know, is opposite over adjacent. So 16 is our opposite side, 30 is our adjacent, and 34 is our hypotenuse. The tangent of E is opposite over adjacent, or 16 over 30. Both of these numbers are divisible by 2, so the tangent of E is 8 over 15. Now we have to find the secant of G. So for secant, we use cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. It's the reciprocal of our cosine. When our theta is in the bottom right-hand corner, 12 is our opposite, 35 is our adjacent, and 37 is our hypotenuse. So the secant of G is hypotenuse over adjacent, or 37 over 35. Now, let's find the cotangent of H. Cotangent is the reciprocal of tangent. Since tangent is opposite over adjacent, cotangent will be adjacent over opposite. With our angle in the upper left-hand corner, 14 is our opposite side, 48 is our adjacent, and 50 is our hypotenuse. So the cotangent of H is adjacent over opposite, so 48 over 14. These are both divisible by 2, so the cotangent of H is 24 over 7. Next, we need to find the cosecant of W. Cosecant is the reciprocal of sine, so 1 over sine gives us cosecant, or cosecant is hypotenuse over opposite. When our angle, our theta, is in the bottom left-hand corner, 6 is our opposite, 8 is our adjacent, and 10 is our hypotenuse. So the cosecant of W is 10 over 6. These are both divisible by 2, so we get cosecant of W is 5 over 3. Last, let's find the sine of P. Sine is opposite over hypotenuse. With theta in the bottom left, we have 20 is our opposite, 15 is our adjacent, and 25 is our hypotenuse. So the sine of opposite over hypotenuse is 20 over 25. These are both divisible by 5, so the sine of P is 4 over 5. Thank you so much for watching. I hope you enjoyed. If you liked this video, please give it a thumbs up and comment down below what other topics you'd like for me to review. I upload new videos every Tuesday and every Thursday at 1 p.m. You can also find me on Instagram and on Facebook at the A+ Tutor. Those links are in the description below. Feel free to leave me any questions or comments there as well. See you next time!